Hi students, welcome to today's class. Today I am going to start a very important chapter, that is binomial theorem. So in algebra, this is one of the very important chapter, that is binomial theorem. So in the binomial theorem, so you are getting at least one question or one or two questions in your JEE mains examinations. Not only JEE mains examinations, almost all competitive examinations have this chapter binomial theorem. So this chapter is also important for your board examinations also. So in board examinations also you will get a good number of questions from this chapter. So this whole chapter is fully based on formulae. So fully based on formulae, so you have to have a good memory power to remember these formulae. Okay, so from the basic concepts also onwards I am going to explain. So let us see this chapter. Okay, so the first thing is binomial theorem. So leave it that theorem. What is binomial? Right, everybody knows that a binomial is an algebraic expression containing two terms separated by either plus or minus. Okay, now that is called a binomial. So what are the examples of binomial? So the examples of binomials are, so this is a 3x minus 2y. These two should be unlike terms. Otherwise 2x square y plus xy. So it is a binomial. Otherwise 1 plus x, it is a binomial. Understand? So if you see here 3x square y plus 4x square y, this cannot be a binomial. Why? Because 3x square y, 4x square y, both are like terms. Both are like terms. So you can add them and you can write down 7x square y. Therefore, this is not a binomial. Okay, now. So a binomial is an algebraic expression containing two unlike terms separated by either plus or minus. So into divided by, they cannot be called as a binomials. For example, 2x into 7x square y. This cannot be called it as a binomial. Why? Because 2 17s are 14x cube y. 14x cube y is a monomial. Just like division also not possible. 2x by 7x square y. So this is also not a binomial. Okay, now it is a monomial. So on the whole, you know what is binomial. Okay, right. Coming to the next topic. So this is a first topic. Second one is, now what we are going to see, if a number is raised to some power, we know what happens. For example, 2 power 1 is there, 2 square is there, 4, 2 cube is there, 8, like that. If a number is raised to some power, then you know how to calculate that value. At the same time, if a binomial is raised to some power, then what happens? For example, x plus y whole power 1, it is raised to the power 1, we know that x plus y. Now x plus y whole square, this binomial is raised to the power 2. Then what happens? You know, x square plus 2xy plus y square. Formula you know. Next one, if it is the binomial is raised to the power 3, then what happens? X cube plus 3x square y plus 3xy square plus y cube. Like that you will get. We know that x plus y whole power 4, x plus y whole power 5, like that. If the binomial is raised to the powers, we know how to find out. Okay, now. Here the thing is, what do you observe? So this is called expansion of the binomial. So this is called binomial, x plus y whole cube. X plus y is a binomial. So x plus y whole cube, whatever may be in the right hand side, that is called expansion of the binomial. Okay, now. X plus y whole cube means what? What is the actual meaning of that? X plus y into x plus y into x plus y. 3 times you have to multiply and you have to expand it and you have to simplify it. Ultimately, you will get the answer. The first thing what you have to observe is, see the number of terms. See the number of terms. Here the power is a 3. If it is a power is a 3, first I am going to explain for a positive integers, that means natural numbers, 3. Then see the number of terms, 1, 2, 3, 4. 4 terms are there. If it is a power is 2, see here 1, 2, 3. 3 terms are there. If the power is 1, there are 2 terms are there. So the first point that you have to learn is If the expansion, the power is n, the binomial power is n, therefore the number of terms are n plus 1. Number of terms are 1 more than the power. Okay, now that is the first one. Second one, observe the degree of the each power, degree of the each term. See here, first term, this is second term, this is third term, this is first term. Here what is the degree of the binomial? 3. Here what is the degree of the first term? 3. What is the degree of the second term? 2 plus 1, 3. What is the degree of the third term? 1 plus 2, 3. What is the degree of the fourth term? 3, 3, 3, 3, 3. Everywhere 3. If it is a 2, degree is 1, degree is 1. 2, 1 plus 1, 2, 2. So everywhere degree is 2. Understand this? So degrees are same. That is, the degree of the binomial is same as the degree of each and every term. That is the second point that you have to say. That is regarding degrees. Third thing what you have to observe is, in a binomial, so you have to write in a systematic order, you have to write down. Observe the degrees of the x here, variable x. So x cube, next x square, next x power 1. Last term there is no x term. Next one, observe the y degrees here. First term there is no y. So here y power 1, y square, y cube. In the first term there is no y. So we have observed that how many terms are there. What about the degree? What is the exponent of each x and y also observe. Now the problem is arises these coefficients. Here x square coefficient is 1, 2, 1. Here x cube coefficient is 1, y cube coefficient is 1. Here 1, 3, 3, 1. 1, 3, 3. So how to find out those coefficients? Now I will write down x plus y whole to the power of 4 term. X plus y whole to the power of 4 expansion I will write down. So this is equal to x to the power of 4 plus 4 into x cube into y. That's 6 into x square y square plus 4 into x y cube plus y to the power of 4. So x to the power of 4, x4, x cube, x square, x, y square, y cube, y power 4. So you see the expansion of the binomial. That is x plus y whole to the power of 4. Understand this? Now 1, 2, 3, 4, 5. We got 5 terms, x power 4, x cube, x square, x, no x. Here no y, here y square. So what about these coefficients? So here 1 is there, here 4 is there, here 6 is there, here 4 is there, here 1 is there. So then how to find out those coefficients? Okay, now I am going to explain how to find out these coefficients. Okay, now so let us continue. Don't go away. So I am going to explain here a very, very important topic here. So from that, this is the idea given by a great mathematician, Sir Isaac Newton. He got the idea how these coefficients are varies. See these coefficients here, 1 is there, 3 is there, 3 is there, 1 is there. Of course, Pascal is also given one rule. But what I am going to give the idea is given by the great mathematician. So don't go away. So I will going to explain that idea. Okay now. Welcome back here. So I am going to explain the idea given by the great mathematician Newton. So here x plus y whole square. So this is equal to x square plus 2xy plus y square. Observe here x square coefficient is 1, y square coefficient is 1. Okay. Now observe here xy. The terms x and y can be arranged in how many ways? Number of arrangements of x and y is given by 2 arrangements. That is xy and yx. Understand? X and y, 2 distinct items can be arranged in how many ways? xy and yx. So this is given by the formula 2C1. 2C1. Understand? I put it like that. Next one you take x plus y whole cube. This is x cube plus something we don't know, x square y plus something xy square plus y cube. So if you want to find it, of course we know that is a 3, 3. Now number of arrangements of see here x square y. X square means what? There are 2x and 1y. That is a x, y. This is given by the formula. See here, in permutations and combinations, we have one formula. What is that? There are total n items are there. So, n distinct items are there. N distinct items are there, in which some p items, q items, some r items are alike. Alike means what? Same. Alike means are same. Total number of items are n, in which p items and q items and r items, p items are alike, all pens. Q items are alike, all pencils. R items are alike, all erasers. Those are the arrangements. If you want to find out the number of arrangements, so number of arrangements is given by the formula n factorial by, what are the things repeated? So that is a p factorial into q factorial into r factorial. So what are the things that are repeated, number of times repeated, that we divide with p factorial into q factorial into r factorial. If all n items are distinct, then the number of arrangements are n factorial. Okay, now, right. Here also, how many x are there? 2x are there, 1 y is there. Altogether 3, that is equal to 3 factorial by. See here, x is repeated 2 times. That is a 2 factorial into 1 factorial. Y is repeated only 1 time. At the same time, so see this value 3 factorial by 2 factorial into 1 factorial, how much? That is obviously 3. Again, number of arrangements of xy square. Xy square means what? X, y, y. 2y's 1x. So this is given by the formula 3 factorial by 1 factorial into 2 factorial. This is nothing but 3. Understand this. That 3, can I write down this as a 3c1 and this can I write down 3c2. So this formula is nothing but 3 factorial by 3 minus 1 factorial into 1 factorial. This is 3 factorial by 3 minus 2 factorial into 2 factorial. That means the expansion of x plus y whole cube is equal to x cube. So if it is a x square y, so this is a 3 factorial by 2 factorial into 1 factorial plus xy square is nothing but 3 factorial by 1 factorial into 2 factorial plus y cube. Understand this? Y cube. Next thing, if it is x plus y whole to the power of 4, if it is x plus y whole to the power of 4, now we can write down easily. This is a x cube plus, next here x cube by x cube y. So what is the coefficient here? The coefficient is this. This is equal to 3 plus 1, 4 factorial by 3 factorial into 2 factorial. So x is repeated 3 times. 3x and 1y can be arranged. This is nothing but the coefficient. The number of ways of arrangement of 3x and y1, 1y is nothing but the coefficient of x cube y. Next one is, what is the next term? Next term is this. This is a x square y square. X square y square. Understand? So what is the here? 4 factorial by 2 factorial into 2 factorial. The number of arrangements of 2x and 2y is given by total 2 plus 2, 4 factorial by, in that total 4 items, 2x and 2y's are repeated, 2 factorial into 2 factorial. Next term is, the next term is plus xy cube. Xy cube. So what is the coefficient of x cube, y cube? So this is a 4 factorial by, this is 1 factorial into 3 factorial plus next last and final y to the power of 4. What is the y to the power of 4? 4 factorial by 4 factorial by 4y is repeated how many times? 4 times it is repeated, therefore 4 factorial, 4 factorial. Here also, here x to the power of 4. So this is a 4 factorial by 4 factorial. Okay now. So this is nothing but, so we can write it as a 4c0 x power 4. Therefore, this is nothing but n factorial by n minus r factorial into r factorial. So this is a 2 factorial, we have to write down 1 factorial. So that is nothing but 4c1, that is a x cube y. So this is nothing but 4c2 x square y square. This is nothing but 4c3 xy cube, nothing but 4c4 y to the power of 4, y to the power of 4. Understand? This is the idea got by the great mathematician Newton. Understand? He thought that, so how this, he did number of expansions he got, and he studied these coefficients. So the only thing is these are okay, x terms and x y terms are okay. The powers of x are going on decreasing, the powers of y are going on increasing, and the sum of these two powers, the sum of the index powers is equal, sum of the both the index is equal to the degree of the binomial. That is okay. The problem arises where the problem arises means this coefficient. So he got the idea then how to find out those coefficients, means he got the idea this coefficient is nothing but, the coefficient of x square y square is nothing but the number of arrangement of 2x and 2y's. The coefficient of xy cube is nothing but the number of arrangements of 1x, 3y's. Nothing but total 1 plus 3, 4 items. Out of 4 items, 1x and 3y's are there. That's why 4 factorial by 1 factorial into 3 factorial. Understand? This 4 factorial by 1 factorial into 3 factorial, in a notation, we write it as 4c3. That means 4 factorial by 4 minus 3 factorial into 3 factorial. 4 minus 3, 1 factorial into 3 factorial. Understand this? Okay now? Right. So we will continue now we will generalize this. If there is a x plus y whole to the power of n is there. So we generalize this, and there is another great mathematician is there. So his name is Pascal. He introduced it another way. He introduced another concept to find these coefficients. Okay. Let us see the Pascal idea also. Okay now. Welcome back. Then we are going to see the Pascal method of finding the coefficients. Okay now. Right. If the degree of the binomial is 1, the binomial coefficients are 1 and 1. So binomial coefficients means just now what we have discussed. All these NC3, NC1, NC2, 4C0, 4C1, 4C2, all are called binomial coefficients. So he said that binomial coefficients are 1 and 1. If the degree is 2, the degree of the binomial is 2, the binomial coefficients are first already starting, the first term coefficient is 1 and the middle term coefficient is 1, 2 and it is given. This is a 1 plus 1, 2. If the binomial coefficient is 3, then the first term coefficient is 1, last term coefficient is 1. Coming to the middle two terms, for if it is a binomial coefficient is 3, the number of terms are 4. So here you will get 1 plus 2, 3 and 2 plus 1, 3. So therefore the binomial coefficients are 1, 3, 3, 1, 1, 3, 3, 1. If it is a 4, the binomial coefficients are 1, 1. So here you will get 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1, 4, 6, 4, 1. Understand? So 1, 4, 6, 4. These are the binomial coefficients. That is a 1, 2, 3, 4, 5. 5 terms, 5 coefficients. Understand this? Okay. It is also a very nice idea, but it is a very difficult if the binomial coefficient is more. For example, if it is a binomial coefficient is a 10, for example, therefore how many degree of the binomial is 10, then how many terms will come? There are 11 terms will come. So if you want to find out the 10th row, you have to know 9th row. If you want to find out 9th row, you have to find out 8th row. So that means all the coefficients are depends upon the previous coefficients. Understand this previous coefficients. Okay na? So this is some, that's why this is a failed, but the idea is very nice. Idea is very nice. Okay na? Right. So that's why Newton's formula success. Why? Because in the Newton's formula, whatever may be the degree of the binomial, so we can write it the equation. Okay na? I hope that this binomial coefficients concept is useful for you. Next we will going to see if the binomial exponent is somewhat large, how to find out the total expansion, and we are going to generalize the formula. Okay na? Now welcome back to the concept here. So here what I am going to see here, I am going to generalize this binomial expansion. So before that, so let us find out the expansion of binomial expansion of x plus y whole power 6. Now what is x plus y whole power 6? The first term is x power 6. Next we will get, okay, binomial coefficient I will write down afterwards. Then what we will get? X power 5 into y. Next what you will get? X power 4 and y square. Next what you will get? X cube into y cube. Next what you will get? X into y to the power of 4. X square into y to the power of 4 plus one extra term what you will get. So this into x to the power of, so this is equal to x into y to the power of 5. Next term is y to the power of 6. No x. Okay. Then how to write down the binomial coefficient? So see here total 7 terms are there. 1, 2, 3, 4, 5, 6, 7. 7 terms we got. Obviously, the coefficient of this first term, that means 6 factorial by 6 factorial 1. So here also 6 factorial by 6 factorial. Then what is the coefficient of x to the power of 5 into y to the power of 1? This is nothing but the number of ways of arrangement of 5x and 1y. So this is given by total 6 factorial, 5 plus 1, 6 factorial by 5 factorial into 1 factorial. Now what is the coefficient of x power 4 and into y square? This is nothing but the number of arrangement of total 6 items, out of which there are 4x and 2y's. So this is given by 6 factorial by 4 factorial into 2 factorial. So therefore, so same logic applies. So 6 factorial by 3 factorial into 3 factorial. 6 factorial by 2 factorial into 4 factorial, 6 factorial by 1 factorial into 1 factorial, that is 6 factorial by 6 factorial 1. Now the final expansion is, so this is nothing but x plus y whole power 6. This is x power 6. This is nothing but NCR formula. So the NCR formula is nothing but n factorial by n minus r factorial into r factorial. Understand? So like that you write down. So this is nothing but 6c0 we can write down here. 6c1 x to the power of y and 6c2 x power 4y square. 6c3 x cube y cube plus 6c4 x square y to the power of 4 plus 6c5 x y to the power of 5. 6c6 y to the power of 6. Understand? So this is the binomial expansion. Okay now. Now we are going to generalize this. That is, if n is a positive integer. See here, positive integer means n belongs to set of natural numbers. Positive integers means natural numbers. So here power only, I am taking positive integers only. This I am discussing this. Afterwards, if it is a negative integers, what is the expansion? If it is a rational number, what is the expansion? That we will see in the later class. So today our discussion is only with the positive integers, that means natural numbers. So that means x plus y whole to the power of n. Now what you observe here? The first term is nc0 x to the power of n. Understand? Next one is x to the power of, here what I am telling, here 6 is there, next 5 will come. So if it is n is there, n minus 1 into 1. n minus 1 into y power 1. That means what? The number of arrangements of total n items, out of which there are n minus 1 x are there, there is only 1 y is there. So this is nothing but n factorial by n minus 1 factorial into 1 factorial. That is nothing but NC1 formula. Okay now? Right. So I can write down directly. So this is a NC1 plus NC2 into x power n minus 2 into y square. So now this so on. In general, I am going to write a general term. See here, x power n minus 1, x power n minus 2, it is go on decreasing. Let there is a middle somewhere x minus r into y power r will be there. X power n minus r into y to the power of r is there. What is its coefficient? This coefficient is n factorial by just now n minus r factorial into r factorial. So in this total n number of terms are there, x and y, out of which n minus r x are repeated and r number of y's are repeated. So therefore total arrangement is how much? N factorial by n minus r factorial into r factorial plus so on. The last term is y power n. So this is nothing but NCn. Understand this? Okay. So this is the formula for binomial expansion. So in this, this will be which term? General I have taken middle term, somewhere it is taking general term. What term it will be? So let us see here. If it is a first term, we got NC0. So this is nothing but NCR we can write it as. So this we can get it as a NCR x to the power of n minus r into y power r. Now our question is, which term it is, either 6th term or 7th term or 8th term or plus 1th term or minus 1th term. Let us see that. If it is a first term, what is there here? 0. If it is second term, what is here? 1. If it is a third term, what is here? 2. So if it is a 2, third term. If it is a 1, second term. If it is 0, first term. If it is r plus 1th term. Understand this? So this is nothing but tr plus 1th term, ncr into x power n minus r into y power r. Understand? So here is NCR is nothing but the number of ways of arrangement of n items, of which there are n minus r x's are alike and r y's are alike. Understand this? Understand this? So this is the general term in the binomial expansion. Here n is a positive integer. So this is the formula given by great mathematician Sir Isaac Newton. Okay now. So in this formula, let us see some more concepts. Okay now. Welcome back to this concept. The concept is here. So x plus y whole power n, where n is a positive integer, that is a natural number. We have the expansion as a nc0 x power n plus nc1 x power n minus 1 into 1, nc2 into x power n minus 2 into y square. So on in general ncr into x power n minus r into y power r plus last and final y power n, ncn y to the power of n. Such a long expansion, this can be, see here, plus 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 some of the some terms, xy terms. Okay, now, so this can be, in short, can be written as sigma r runs from 0 to n, ncr x power n minus r into y power r. Sigma r runs from 0 to n, ncr x to the power of n minus r into y power r. So we can expand it. So by putting r is equal to 0, we will get first term. If we put r is equal to 1, you will get second term. And if you put r is equal to 3, you will get third term, like that you will get. Okay now, right. Now what I am going to do is replace r with n minus r, or replace r and n minus r. Both things you replace. Then see what happens. So this is sigma r runs from 0 to n, NCR x power r into y power n minus r. X power r into y to the power of n minus r. Okay, now let us see that. Let us see what happened. What's the expansion is there. So this is nothing but you will get NC0 x power 0 y power n you will get y power n. That means NC1 into y power n minus 1 into x, NC2 into y power n minus 2 into x square, so on last one, NCn into x to the power of n. NCn into x to the power of n. Now we know that in the permutations and combinations chapter, we know that NCx is equal to NCy. This implies x is either x is equal to y or x plus y is equal to n. That means if you replace in place of NC0, you can replace with NCn. In place of NCn, you can replace with the NCn minus 1. You can replace according to that formula. That means here NCr is equal to NCn minus r. Both are same thing. So NCr is equal to NCn minus r also you can write down. So if you replace that, so you will get this expansion as y plus x whole to the power of n expansion. Y plus x whole to the power of n. Why? Because here NC0. So here NCn, NC0 both are same. Again you will get this. Okay, now so this previous term, what will be the previous term? So NCn minus 1 will be there, x to the power of, sorry, here y to the power of, here's what n minus of 1 and y to the, sorry, x to the power of n minus 1 will come. That means x to the power of n minus 1 into y. In place of NCn minus 1, you can write down NC1. Understand? From this concept, what you can observe is the expansion of x plus y whole power n, y plus x whole power n, both are same. Both are same. So we can conclude this. So that means what? For example, 3x square plus y whole power 10 expansion, y plus 3x square y whole power 10 expansion, both are same. Both these expansion, this is the first term, here second term. Here even though we interchange it, y plus 3x square 10, you will get the same expansion. Whatever may be all the 11 terms here, 11 terms will be same. That means the arrangement will be different. Understand this? So from this concept, what have understand? So x plus y whole power n expansion and y plus x whole power n expansion, both are same according to the permutations and combinations concept. Okay, now so let us see one more concept. Welcome back to this concept. So in the expansion of x plus y whole to the power of n, we got the n t1 and t2 and t3 plus so on tr plus so on tn. There are n number of terms will be there. So there are n plus 1 number of terms will be there. If it is a power n, there are n plus 1 number of terms will be there. First term, second term, third term, fourth term, so on, n plus 1 terms will be there. So from the beginning, we know the formula. That means tr plus 1th term is equal to ncr, x to the power of n minus r, y to the power of r. We can find out the term. If you want to find out fourth term, so here r is equal to substitute. If you want to find out fourth term, you substitute here 3. So 3 plus 1, 4, you will get the answer. But now our concept is, this is called tr plus 1th term or general term. So if you want to find out the general term from the end, so p plus 1, since already we are using r here, that's why here we use it here p. Okay, now that means p plus 1th term from the end is same as n minus p plus 1th term from the beginning. For example, if you want to find out 4th term from the n in the expansion of x plus y whole to the power of some 5. x plus y whole to the power of 5 fourth term. That means what? So this is a 1, t2, t3, t4, t5, t6. 6 terms will be there. 1, 2, 3, 4, 5, 6 terms will be there. If you want to find out fourth term from the end, fourth term from the end means what you will get? So this is a first term, second term, third term, fourth term. That means T3 you will get. From the end, fourth term is 3. Then how the formula is here? See here, n means here 5 minus fourth term, that is a 4 plus 1. How much? 5 plus 1? 5 plus 1, 6, p plus 1th term. P plus 1th means here you have to substitute p is, so this is equal to p plus 1th term. So p plus 1 is equal to 4 means p is equal to 3. So here substitute here 3. So 5 plus 1, 6, 6 minus c, 3. This is a third term from the beginning. So on the whole, what you have to remember is, so Tp plus 1 is same as T n minus p plus 1. So from the end, p plus 1th term is same as from the beginning n minus p plus 1th term. Okay, now I hope that you understand this concept. So there are so many terms, concepts are there in binomial expansion, binomial theorem. So I hope that you enjoyed today's class. With some more concept, tomorrow's class I will stand before you. Until then, all the best.